So hello, everyone. My name is Tadeas Kriz. I'm a senior mobile developer at TouchLab. And the last year, I've spent kind of trying to break the Kotlin compiler and trying to get into as much trouble as possible with it. And so I've learned many valuable lessons along the way. However, before I go any further, I want you to hop on your time machine and go see Amanda's talk. It was awesome, and it gives you like a different perspective on what I'm talking about. Or just see it on YouTube when it's out. Now, for the agenda, I already gave this talk at DroidCon New York. And the one thing I realized that I wanted to talk about how to use KSP. I wanted to tell you, like, how do you write Kotlin compiler plugins? Like, what do you have to do? And I wanted to choose, like, do you do KSP or Kotlin compiler plugins? So you would learn how and what to do. However, what I found is that this would do for a workshop, not a talk. So we're not going to do how to use KSP. We're not going to do how to write Kotlin compiler plugins. Instead, we're going to recap what the metaprogramming really is in JVM, overview of the KSP, see like what you can do with it, what's great about it, and what's a little less great about it. And then we're going to look at the Kotlin compiler plugins overview. The last thing, and that stays, is learning what to use, whether you use KSP or Kotlin compiler plugin. And if you excuse me, I'm going to steal water here. So let's jump to it. So what is metaprogramming? Metaprogramming, by definition, is looking at the code you wrote and doing something else to enhance it, make it worse, break it, whatever you want to do, right? The first thing and you already probably know that, how many of you use reflection or are using it in like everyday basis? So everyone's like backend developers, right? I guess. So reflection is great, but the performance on mobile, essentially, backend's a different story, isn't great. Because we need to run the JVM each time, we can't really let it optimize all of that stuff that we would be doing with reflection. So you are paying for like runtime and then all of that stuff each and every time. It's also very limited in native. So if you're doing Kotlin multi-platform and you want to support iOS, anything you do in reflection won't work on native. And you can't even access all of that because it's all JVM. These are very mushy buttons, by the way. So the next thing, compared to reflection, we have compile time introspection. So compile time introspection is looking at the code during compilation, so it's not as dynamic as a runtime one, but is better for mobile apps and works for native. The downside is it brings longer compile times. So this is something you need to be aware when doing this. So you're essentially taking the runtime, the time you would spend in runtime and do it in compile time. Sometimes it's more than that would be in runtime because you need to do more things. It also leads to larger binaries, because you need to generate, usually, you need to generate additional code that will do whatever you want it to do instead of the reflection that would do it dynamically. However, as I mentioned previously, it's necessary if you want to do any metaprogramming for KMP. So let's recap the Java world. Compile time introspection real quick. Starting with APT. How many of you used APT? Oh, that's a lot of people. How many of you wrote a processor for APT? OK, still a solid number of people. Pretty great. Love it. So APT, for those who don't know, it stands for Annotation Processing Tool. I think it was introduced in Java 1.5 under like a different name, but with annotations. And then it got the name and like a stable API in the like Java specification. And then we got to Kotlin with KAPT. KAPT is great. It has like a backwards compatibility, right? You can run anything that was APT with KAPT. It has some downsides though. That's why KSP was born. So KSP is here to solve those issues. So for example, KSP, well, I'm going to get to that in a second. So one of those downsides of the KAPT is it prolongs your compilation time, especially if you need to access Kotlin classes back from Java. And like whatever you generate being accessed everywhere, it needs to generate stubs so that the Kotlin compiler sees them, and then after those stubs are generated, it can like access them during the compilation. Now, KSP, built by Google. Quick vibe check. How many of you are switched to KSP? That's not a lot. How many of you are still staying with KAPT? OK, I need to talk to you why. I'm really interested. So built by Google, endorsed by JetBrains. When you look at the promotional materials, they say it's 2 times faster than KAPT. I haven't verified, so I can't tell for the trueness of that information necessarily. But it's great that it has a stable processor API that looks very similar to what you have in the KAPT, and it supports Java sources. So this is a really important thing for if you have a legacy app, either in Android or a backend, where you still have Java sources. As long as the KSP plugin you're using, or like the processor for the KSP, is supporting KSP APIs, you should be able to enhance Java as well as Kotlin. And it's well documented. Why I'm mentioning that will be explained in a later slide. And it has growing support. So last time I gave this talk, there were less libraries, so I kind of had trouble putting them together. And I guess the next time I'm giving it, it's going to be worse. So that's fun. So you can see there's a lot of previous libraries that were KAPT. Previously, they are adopting the KSP. So if you are not using an old processor that still hasn't come around, switching to KSP can lower your compilation times, depending obviously on your compilation unit size. But I would at least recommend trying that if at all possible. Now the downsides. So KSP, it cannot do code modifications. So it can generate new Kotlin code, and it has this great multi-step compilation. So whenever you generate something, it will run through it again, through the new code. As long as you say, yes, something new was generated, please run again, it will keep running. So that way, you can have multiple annotation processors, and they will work together. If the one generates code, the other one understands, it will run again. No expression-level introspection. So KSP can get you lower than a declaration, right? So you can inspect classes. You can inspect their properties and functions. You can inspect nested classes. But you can get to expressions. You can use KSP to validate, for example. So you won't be able to add new error reporting on strings you use in your code, because you're not going to get there. Now, there is a great KSP Quick Start guide, which you can access on the kotlinlang.org. So I said that it's endorsed by JetBrains. So basically, JetBrains this is the recommended way from now on. Please use it if possible. Kotlin compiler plugins. How many of you wrote a Kotlin compiler plugin? OK, we can talk. Let's make a private session after today. So Kotlin compiler plugins. KSP is a Kotlin compiler plugin, just to note. So it's running in a very similar way. And it's something that if you want to get into Kotlin compiler plugins, Cracking open the KSP source code can be very helpful to just go through, see what they are doing, because they are transforming the existing Kotlin code into the representations that can be then used by annotation processors. And that's often something you want to do too. So when I first learned about the Kotlin compiler plugins, I fell in love with them. I was like, finally, we can get deep into the compilation process, not just having macros everywhere that break every time. And there's a lot to love. So they are extremely powerful, right? Like you can do essentially whatever you want to do. You can transform the IR. So whatever the Kotlin compiler compiles, you can get in there and change it to whatever you like. Do you want to add like a logging wraparound so you can log basically any function? Do you want to do something like aspect programming? Why not? That's all ready for you. You can also do these thing called synthetic declarations. So you can extend your, you can basically create non-existent declarations that you then can access. So, for example, the Kotlin X serialization plugin is creating those serializers for you. So those things, they don't really exist, right? They get generated during the compilation. But with synthetic declarations, thanks to them, you can access them in your Kotlin code. If you just change the IR, you wouldn't get to that. You wouldn't have available, it would just say, it doesn't exist. And then you can go down to expression level. You can really because you have the whole IR and the whole, with the new K2, it's the front-end IR. With the previous front-end, it was the PSI. You can look into anything. Anything that's possible, you can just go in there and inspect, validate, generate based on that, whatever your heart desires. Well, there's also things that kind of break your heart. So when you get into compiler plugins, you're like, oh, it's so good. I love it. Let's do everything in compiler plugins. But you learn that, how do I do that? There's unfortunately little to no documentation, not just a guide to how to do a compiler plugin, but even in the code of Kotlin, unfortunately, these extension points and anything that you're going through, you will have to understand it yourself. It's getting better. There's more and more comments in the code. There's more and more information what different stuff is doing. And there's also more and more to-dos that are saying, this will change, beware. The setup is incredibly complex. So how many of you who created Kotlin compiler plugins did it on first try, no issues, everything worked, you knew where everything was? Crickets. OK, that's what I expected. Good. So, and the last thing, well, not last thing, there's two more, is the unstable API. So Kotlin team purposefully say, do not do this unless you want to accept those risks. They are not going to support the API. It's not meant to be publicly used. It's mostly, those extension points are mostly for them, so they can develop plugins, right? So with that comes, whenever you have a new Kotlin version, depending on the size of your plugin, depending on what you do with your plugin, it's quite possible it will break. And you will have to go in, fix it, and then, going back to the complex setup, configure a deployment so that you release for multiple compiler versions, right? Unless you want to support only the newer one or the older one. But then, who's going to use your plugin? Because if I only can update to your new features with a new Kotlin version, that's kind of a bummer. If I can update the Kotlin version because of your plugin blocking me, that's also a bummer, right? Well, then the last thing, depending on what you do, right? So I mentioned the synthetic declarations. They are visible from the Kotlin frontend if you do it, but you won't see them in IntelliJ. In IntelliJ, everything will be red. It will be like, well, this doesn't exist. Why? because IntelliJ doesn't communicate with the Kotlin compiler. It has its own, essentially. It's running the front end itself, and it doesn't load your plugin. It doesn't know how to, at least not now. Hopefully that will change, hopefully. But you need the IntelliJ IDEA plugin for the IntelliJ to know, like, oh, here, there's the plugin. Use this plugin in your front end, and then the synthetic declarations will be available. And that also goes back to the complex setup, because it makes the setup even worse, right? You need to learn how to do IntelliJ plugin. Not an easy thing to do, not documented well enough. You need to deploy them, right? You need to figure out distribution. With Kotlin compiler plugins, it's even worse, because you are depending not just on the IntelliJ version, but also on Kotlin version. And if the Kotlin version is incompatible with your plugin, it will do this little red exclamation mark in the lower right corner in your IntelliJ, and your users will hate you for it. And you will hate you for it if you're using your own plugin. Speaking from experience. Now, let's look at the plugins. If you are still interested in Kotlin plugins, if you're not like, oh, I'm out of here, let's talk about the structure and the main things you should know that are the most useful for probably the most use cases. This is what is living in Gradle and what is living in Kotlin. So whatever's above the dashed line, that is living in a module that's great. There's a separate module from the lower one. Oops. And so you need to do 2 modules. Speaking of a complex setup, the Gradle module will be loading in the Kotlin module. And so in Gradle, you need to configure your plugin. So that's a Gradle plugin. The Gradle plugin will load the you will create an implementation of Kotlin compiler plugin, support plugin. And these 2 you will put into your Gradle module. Now, the Kotlin module, the command line processor is actually optional. That's why it's in dashed. The command line processor is to be able to bring in properties from outside. So if you need to configure your plugin in any way, you want to do this command line processor and get in the configuration. Then there's the component registrar, which it's not. It's now compiler plugin registrar. So Kotlin 1.8 changed this API in preparation for K2. If you haven't yet, and if you wrote a Kotlin plugin, change this in your code. So it still works, but you know how it is with deprecation. And so this compiler plugin registrar, what it does is it registers extensions, right? And these extensions are what does the main work. What is an extension? Now I see that I forgot to change this. This is the old API, so you're gonna have to change. You will see similar register plugin extension points in the component registrar. This is the old one, but it works the same way. You have all of these. So these are extension points. You can get in and create an implementation of any of those, and then register them. And Kotlin will, depending on what you're compiling, what the extension is doing, run it, or maybe not. But the thing that is most important are these 2 on the top. So it's the synthetic resolve extension and IR generation extension. Real quick, how many of you didn't upgrade to JVM IR? Cool. So yeah, you won't need any, you will need the synthetic Java resolve in that case. Now, the synthetic resolve extension already talked about adding synthetic declarations. You can create new classes. You can extend existing classes. So you can, the synthetic resolve extension will get called with existing declarations, And you can tell Kotlin to add new properties, add new functions, add new classes. And then you can implement them in IR later. And as I mentioned, this is needed for, this extension is needed if you need those visible from your Kotlin code. If you're just generating stuff that will be running in the runtime and it's not to be used from Kotlin, you aren't gonna need this. However, if you want this to be visible for the customers or consumers of your plugin, you need the IntelliJ plugin as well. Then the IR generation extension. So you can add and modify declarations. It's very similar to the synthetic resolve, but the synthetic resolve is basically saying there's some new things. What they are, how they work, what they are is also the synthetic resolve. So it's like the name and the type. But then the IR generation will say what they do. So, for example, you can implement these synthetic declarations in a way that you have properties, and you can add fields to properties that don't normally have fields. And you can modify the IR down to the expression level. So, whatever you want to do, the IR generation extension has the power to let you visit all the things that in the IR, and Amanda is going more into what the IR looks like, what it does, how it's going through lowering processes. So again, want to shout out, definitely watch that. But this way, you can do whatever you want with your code. So it's really powerful. Now, I want to share with you my approach to doing the compiler plugins and experimenting with Kotlin compiler and exploring it. Hopefully, from now, more people will raise their hands when I ask about who wrote a compiler plugin. So my approach is to crack open the Kotlin code, right? So let's set up the project. We clone Kotlin, open IntelliJ, create local properties, put in some stuff. So the first one is to disable JDK, I think 5 and 6, because they don't like to work on Mac, and I couldn't get it to work. So it was easier to just disable them, because I don't care. And Kotlin native enabled is to, if you want to do Kotlin compiler plugin for multi-platform, you definitely want the native to be there, so you can step through the native compiler as well. Now, I think I had to do with at least with the 1.820, I don't know the previous versions, is adding this in the Gradle properties. It might be because we're on an open Wi-Fi and I downloaded weird stuff now that will break my laptop. Hopefully not, but this, I was getting an error that a dependency is not having the right checksum, so I had to say hey Gradle, let's not care about that. Let's throw security out the window. It's fine. And then synchronize in our IntelliJ. That's not all. So if you want, I'm specifically looking at and focusing on the KMM project, but this also applies to any other project. But with a KMM project, you want to run the Kotlin native Gradle task. So for example, here I'm running the compile Kotlin iOS ARM64, which will build ARM64 binary for iOS with the -info. And the reason for that is it will give this transferred arguments equals something in the Gradle output. So you want to copy everything in there between the brackets, except the con and C. And we're going to use that. We will put into the local properties file this conan.debug.args, debug.args. We want to use the verbose phases because they will produce better output for us when we're running the compiler. And then we put those arguments. So as I mentioned, this is for Conan C, which is the Kotlin native compiler, but I believe it's similar for the JVM one. I haven't used it in some time, so I don't want to lead you astray. And then let's look around. So we add breakpoints, Like, you can open existing implementations of those extensions I mentioned and just put breakpoints in them. Run this. This will build Kotlin native, and then run the native compiler in debug mode. Whatever you do next, that's up to you. In the end, hopefully profit. I have some more things I kind of learned along the way that I wish someone else kind of like posted up before me. IntelliJ may not stop on your breakpoints in the Kotlin compiler when you're going through it. It depends on how you're running it, whether you're running it on your project or whether you're running it directly from IntelliJ. Make sure to add this into your Gradle properties if you're doing this kind of work. It's going to slow down your compilation, so don't put it in like the global user Gradle properties. You don't want that. But for debugging and working on the compiler plugins, put it in. It will stop on breakpoints. At least so far it's working. And then these are the like fun things in synthetic resolve extension. So what can happen is that the Kotlin compiler essentially asks the class descriptor for properties, right? So it's like, what properties do you have, class? And the class like, well, I do know what properties I have declared, but I want to check whether they're synthetic properties. So it's going to ask synthetic resolve extensions. It's going to be like, oh, I'm this class. What do you want to add? What do you want to add? And then in your synthetic resolve extension, you're like, well, let me show, like, give me your properties first so I can know, like, I want to generate all of them with underscores. And it's going to crash. Because you create a loop in this sense where it's already asking you for the properties and you're asking it. There are ways to work around that. They are all weird. And I would implore to talk to someone from JetBrains if you need this. I couldn't find a way that would work in all cases. So if you need to like depend on existing properties in a class and create new properties in the same class, same applies for methods. I don't know. It's just something that breaks, and it's frustrating when you're trying to debug it and trying to find a way, and then you're like, well, I can't find it. And I think that's the last like hard-learned lesson is Kotlin native is incredibly strict. When you change IR, if you're gonna go and write Kotlin compiler plugin for JVM IR, you can do basically whatever, and it's kind of gonna work usually. In the Kotlin native, you have to make sure that like there's like start index and end index in the IR. All of that you need to fill it in. For example, you have like if you're calling a generic method, you need to make sure you're passing generic type. It's not required because like it can't tell you what to put in, right? It's all kind of like give me what you want me to generate in the IR. If you don't give it to it, it will, like, sometimes it will crash in linking, sometimes it will crash in compile. The crashes are all weird. It's like, oh, I can't find this symbol, and it's all completely different symbol, for example, right? It's difficult to debug. So just make sure that when you're going through and then generating IR for the Kotlin native, you basically have to set everything. You need to make sure that everything's there. And when you are debugging like a weird crash, go back to wherever you're creating new declarations in the IR and look for maybe a missing property that you didn't set, maybe a missing parameter that seems a little weird, little off. It's usually those places. It's difficult to say exactly because it really depends on what you're doing and so on. And OK, so it wasn't the last thing. Maintenance of a Kotlin compiler plugin is so difficult. So Kotlin releases, as I mentioned, change API. And they change it in a way where like sometimes it works, but fails in kind of unpredictable ways. So you kind of want to build an infrastructure to test your plugin with multiple versions. And I hope you're going to write tests because you're going to need them. It's like really important for the compiler plugin if you write them to have tests, because there's so much that can go wrong. Sometimes you try and then it works and it's fine, and then it's going to fail in the most spectacular ways. Now, would you like to know more? Some people don't, already left. I'm fine, I'm not hurt at all. No, I'm kidding. So if you would like to know more, there's multiple repositories I'm listing here where you can go through and kind of look at their code. So on the left, there's a repository, and it's a link, so when the slides are available, you'll be able to go in and just click that. And then on the right, you have where the source code that is interesting resides. So, for example, in the Kotlin repo, you have the plugins directory. Go in there, look at their code. Basically, like, copy over stuff that you might think are doing what you want to be doing. They will either work or not, but it's going to give you at least some, like, sort of a documentation, give or take. The one thing I'm not mentioning here is, no, I am. OK, so that's the Android X repository. You have the Compose compiler. It's one of the best examples of Kotlin compiler plugins, because they are doing so much great work, and it's like doing so much stuff in the background for you. So when you need to do like something very specific, something very complex, looking what they are doing can help you understand, like, OK, I need to manage state and create like weird new expressions. Well, they probably are doing it in Compose because it's so complex, right? So, and then, as I mentioned previously, the KSP, when you need to know, OK, this transforms the Kotlin to like the annotation processor kind of API, it's there. Two more things that, if you want to, you can go through, doing like different things. It's more like maybe they do stuff you want. Go ahead and copy it. It's open source, right? You can copy over everything you want, as long as you attribute, right? When I gave this talk the first time, I was asked about the K2 compiler. My answer is, no, I'm not going to go into it. But tomorrow, there's a talk on K2 compiler plugins by, I hope I pronounced it right, Mikhail. Sorry, butchering the name. So I am definitely going to be there, because I'm really interested, and you should be too if you're interested in the K2 and in the future of compiler plugins. So, do we use KSP, or do we write a Kotlin compiler plugin? So do we write an annotation processor or a plugin? It's easy. Just follow this flowchart or whatever it is. So, do you need to modify existing code? Well, if you do, ask yourself again, are you really sure? Is it like just your preference that it would be nicer if it was generated inside a class? Could it just live outside of it with a different name? Maybe. Well, if you still are like, yeah, we need to change the existing code, or access expressions, right? Then yeah, go for it. Write a compiler plugin. But, and I want to stress this but very much, use KSP, write annotation processors wherever possible. They have stable API for your processor. So it might happen that KSP won't have a new build for like the latest Kotlin for a couple days maybe. But it will not break your plugin. You won't have, like, your processor. You won't have to go back and change whatever you did half a year ago with the last Kotlin release that broke it, where you don't remember what you did anymore. With KSP, they say the API is stable. They will add to it, but they will not change it unless they, like, somewhere major version, right? Let's talk about testing. There's Kotlin compile testing library, I guess. Down there is a link. I don't know how much it's visible. It's mostly for when you get the slides, you can click it. But the Kotlin compile testing is great in, it basically runs the Kotlin compiler during your, you can use it for like unit tests, integration tests, whatever, but it's running the compiler. So you will give Kotlin compile testing your plugin, and it will run the compilation on whatever code you provided and give you the result. It also supports KSP, so if you're not gonna do, and again, I implore you don't, unless you absolutely have to, write a Kotlin compiler plugin, but a KSP annotation processor, you can still use the Kotlin compile testing to test your KSP annotation processor the same way you would test the Kotlin compiler plugin. The only thing is it's really slow because you have to compile, and compilation takes time. But with the K2, hopefully, from what we see in the keynote, haste is gonna get faster, so I'm really stoked about it. Kotlin multi-platform and how this all comes together. So we already know that the compiler plugins are used for serialization. They can be used for dependency injection that is checked during compile time. It's being used for Jetpack Compose. It's being used for Zipline, which is pretty cool. Definitely go look into that. And it's also used for this little library that I'm going to do like a shameless plug for. We have built Sky, which is a compiler plugin that plugs into the link phase and improves the API that your iOS developers on KMM would see. So it generates a bunch of Swift code and then links it directly into the framework. So whatever your iOS devs are doing now, if they're like, oh, we don't want to use this because we don't get flows support and we have to like use this weird wrapping by KMP native coroutines, you can tell them like, yeah, with this we can just use that and be all good because it all supports that. On there you can see like what features are in Sky and see whether that's a good fit for your team. Now, I'm gonna wait a little bit. Cool. Recap. If you can, stop using KAPT, and I'm sure that all of those who haven't done that yet have a good reason not to. But try to like periodically check whether your whatever processor you're using hasn't been updated for KSP already, or maybe there's a fork. Like yesterday, I learned that there's a fork of autoservice from Google, and that, well, the fork isn't from Google, but the fork is for KSP, which is something that I've been missing, and one of the reasons, one of the projects I was working on couldn't be updated to KSP. Now I guess we can. Now, I'm gonna say it again. I hope that this repetition will kind of give all those who might be like, yeah, we could use compiler plugins, some doubts, more doubts into that. And like, it might be too risky. So like, really prefer KSP where possible. And remember, compiler plugins are so powerful, but costly. It will cost you in the long run, so you need to make sure that whatever they are bringing you is worth the cost. So if it's compile time safety, usually it's going to be worth the cost. If it's just to make the code a little better, it might not be. Now, from what I've been talking with JetBrains folks and people working on Kotlin, I think that the question mark should be removed now. The future is definitely bright. We are getting better documentation. We are getting the new K2. It's so exciting. I'm really excited like what's coming next. What can we build with K2? And hopefully, with the new documentation, will come a better like distribution process. Hopefully, we'll be able to not need to write IntelliJ plugins, so we don't have to distribute that, and all of that might be in our future, hopefully. Do we have questions? We have 4 minutes for questions. Thank you. Before we get the mic, I want to say if okay,
It works. Yeah. If somebody have questions, we can handle a couple of them.
I think there's in the back.
Okay, yeah, I'm close.
I just want to say, if any of JetBrains folks are here, anyone working on Kotlin, and is going to ask me a question, please don't. You know way more than me, and it's going to be awkward.
Yeah, you told about the API for the compiler plugins, which was instable, not really usable outside of development of plugin. But is there do you know if there are plans to make it stable in the long term? So with the proper documentation and example, or will it stay unstable and with the change with all new version?
Yeah, thank you. So the question is whether I know about plans to make this all stable, and then like the plugin API being public, and like this is what you use and robust. I don't. What I keep hearing is like, it might be. Hopefully it will be. Like, that's my personal hope, that it will stabilize. But I also understand the development team. Compilers are difficult. There's so many moving parts and everything, and you don't really want to like constrain yourself to some API. So what I would expect is like, oh, we're slowly going to like make some of the API stable. So you're like, this is stable, this is alpha, and this is experimental. Don't touch that. So like, but that's what I would expect, and I don't work at JetBrains.
Is there more questions? Yeah.
Oh, I didn't get to show my beautiful animation. Can we get the slides back up, please? Or is it my Mac? Oh, sorry. That's on me. OK, thank you. Oh, we have questions. Sorry, I got a little distracted.
Let's say I want to generate some code, but not necessarily with anything related to annotations.
Yeah.
And I still use KSP for that?
So the question is whether you can use KSP without annotations. And it's a good question, which I don't have an answer from the top of my head, because I guess I haven't tried. I'm always like, the stuff I'm usually working on right now is the compiler plugin, which cannot be done with KSP. But I would expect so, because it like runs your processor, and like you don't like, you ask the processor for stuff. Sorry, the processor API, the KSP API for like, give me stuff annotated with something. And this like extension, this processor, is called when you register it. So you can make sure that it will be called. What I don't know right now is whether it will give you all declarations. But I would expect it would. It would make sense if you're already there. And I think the like Java annotation processor allowed to do the same. It does not? It does work? Oh, perfect. Thank you.
Thank you.
OK,
So,
I think we're out of time.
OK, 20 seconds for this. So get in touch. This is my Twitter, which I try not to use anymore. So, and that was the animation. I was like, oh, I couldn't show it. Oh, thank you. I didn't believe that animation was so beautiful. It was all Keynote, though. It's all magic move.